we're going to look at the relationship between radical expressions and rational exponents. Rational exponents are just exponents that are fractions, and we can use it as an alternative notation to radical expressions. This allows us to apply our rules of exponents from Chapter 5 in order to manipulate radical expressions. So we're going to start with the most basic, which is a to the power of 1 over n, meaning we have a numerator of 1 and a denominator of some positive integer value. And so we can rewrite it as the nth root of a. And so simply put, we just say that the denominator becomes our index, and then our base is our radicand. And so a lot of times what we can do is take something that's in rational exponent form, write it in radical notation, and then this will sometimes even allow us to simplify. So we're going to go ahead and do that. The 4 to the power of 1/2, 2 is our index, meaning we have a square root, and 4 is our radicand, so that's going to go inside of the radical symbol. And since we can take the square root of 4, that ends up equaling 2. Our index is 3, so it's the third root of 64, and that equals 4. Our index is 4, so we have the fourth root of x. Now I can't take the fourth root of x, so that's as simplified as we can get it. Our index is 6, so we have the sixth root of 0, and the sixth root of 0 is 0. Now we need to be very careful when we have negatives and whether we have grouping symbols or not, because keep in mind this negative is not part of the base 9. It is on the outside, so our radicand is simply 9. We want the square root, and the negative goes in front. So that gives us a -3. Conversely, if I had the negative square root of 9 to the 1/2, it would be the square root of -9, which is non-real. All of this is our radicand, and our index is 4, so we have the fourth root. We can take the fourth root of each of these, giving us 3x squared. My base is y, and my index is 3, so we end up with 5 times the cube root of y. Let's take a look at what happens when our numerator is something other than 1. We have some different positive integer value. Through our properties of exponents, we can expand this. So 2/3 is equivalent to having 2 times 1/3. And using the power rule of our exponents, we can expand on this as either writing it as exponent of 1/3 to the second power, or second power raised to an exponent of 1/3. Either way works. And so using that, we can kind of simplify expressions in different ways and say, well, I know how to write 8 to the 1/3 power. That's just the third root of 8. And then after the fact, we go ahead and square it. Conversely, we say, okay, well, I just have 8 squared, so that's my radicand, and then I can take the third root of that whole expression. And so our property becomes that when we have a fraction as our exponent, and we can write it in lowest terms, then our radical, our numerator, will become the exponent of the radical, and our denominator will still be the index of our radical, with the base being the radicand. And either notation, with the exponent on the outside or the exponent inside the radicand, will give the same result. And we can look at our previous example to prove it. The third root of 8 is 2. 2 squared equals 4. 8 squared is 64. The cube root of 64 is 4. So whether we do the root first and then exponent or exponent then root, we get the same result. Now, generally speaking, this notation is often going to be the easiest to evaluate. Especially depending on our numbers, it's easier to make them smaller by taking the root and then raise the exponent, rather than use the exponents to get a much larger number that we might not know the root of without having to use our calculator. So let's apply this property to simplify some of these exponents. So our index is 2, so we have a square root of 4 raised to the third power. We could also write it with the 4 inside the radicand. Either one is fine, but the one on the left is going to be easier to solve. The square root of 4 is 2. 2 to the third power is 8. Now again here, pay attention to our base. Since there's no parentheses, we know that the negative is going to go outside. Our radicand is 16. Our index is 4, so we'll have the 4th root of 16 to the third power, and then our result will be negative. The 4th root of 16 being 2, and 2 cubed equaling 8. The negative is inside parentheses, meaning our radicand is negative 27. We have a third root, our denominator is 3, and then we're going to square that. So the cube root of negative 27 is negative 3. And then we'll square that entire expression to get a positive 9. Within our fraction, that will be our entire radicand. We'll have a square root because our index is 2, and then we'll raise it to the third power. The square root is 1/3. 1/3 to the third power is 1 over 27. Our radicand is 4x minus 1. Our index is 5, and our exponent is 3. Now, if we decide to write it with the exponent inside the radicand, which we can, we just need to make sure that we're applying the exponent to the entire expression. If I write it like this, the only thing that's getting the exponent is that 1. And so I need to make sure that I put the entire expression in parentheses to ensure that the grouping is correct. Now let's take a look at our last rule for radical notation, and that's if we have a negative exponent. Now remember, a negative exponent just says, hey, let's take the base and write its reciprocal, and then we can make the exponent positive. We are not writing the reciprocal of the exponent. So let's take a look now at our first example. So we have the negative exponent, which means we're going to take 64 and write its reciprocal. The reciprocal is 1 over 64. Now, generally speaking, that entire fraction is being raised to the 2/3 power. Using the power rule, that means we're going to have 1 to the 2/3 power over 64 to the 2/3 power. But 1 to the 2/3 power just equals 1, so it doesn't really make any difference. So generally, we just use the shorthand and just apply the 2/3 exponent to the denominator. And so now we can write it in radical notation. Third root of 64 squared. Third root of 64 is 4, and then we square it, we get 16. Now here, again, pay attention, that negative is not as part of that base. And so we'll use the negative exponent, and we'll say, okay, we have negative 16, 1 over 16, to the 5/4 power. Write that a little bit bigger, 16 to the 5/4 power. So we wrote the reciprocal of 16, which is 1 over 16. Our entire fraction is negative. So we have negative 1 over the 4th root of 16 to the 5th power, which is 1 over 2 to the 5th, which gives us 1 over 32. Again, we're going to write the reciprocal of 64, but that's in our denominator. So, strictly speaking, it's 1 over 1 over 64 to the 2/3 power. And when we have a numerator divided by a denominator, it's 1 divided by the 1 over 64 to 2/3, which is 1 times the reciprocal. So again, usually we just kind of use the shorthand where we can make our exponent positive, and this moves up to our numerator. And so let's apply that shorthand where we just have 64 to the 2/3 power. Cube root of 64 squared. 4 squared is 16.